Hi everyone. In today's video, I will be going over the notes for graphing rational functions. These are pretty comprehensive, so I figured I'd make a video to discuss them further. Few things before I jump in. I'm going to do 4 examples with you. There's a lot to it. You want to make sure you have this paper handy. If you don't have it, it is linked on the agenda. And then on top of that, you will want to have your graphing calculator handy because we're going to be typing some things in, and it's really a helpful tool, as always, to use. So, example 1. Our function is f of x equals 2x plus 1 over x plus 1. So this paper is basically the step-by-step how to solve these problems, how to graph them. So the first step is to factor. If you look here, we cannot factor this down. We have a 2 attached to this x, and we don't have 1 on the bottom. If there was a 2 in both places, we could absolutely factor this. This would just become 1. But we can't factor anything else out of this. So step 1 is really not a step at all that we have to worry about. Step 2 is look for holes. Factors of the numerator cancel with factors of the denominator. So that's when you have something on top and bottom that cancels out. Again, we don't have this here. So for the first thing I will note, holes, none. We don't have any holes. And holes will make more sense once we have an example that shows you what we mean by holes. But for now, no holes. The next thing we have to look for is the vertical asymptotes. So going back to our paper, after dividing out the holes, which we didn't have to do, set the denominator equal to 0 and solve. So we're going to take the denominator, x plus 1 equals 0. Solving for x, x equals negative 1. So our vertical asymptote is x equals negative 1. And you do have to write it that way. It is an equation. It is a line through negative 1 on the x-axis. Next, we have our horizontal asymptotes. Now, there are a few rules for horizontal asymptotes. Let me go into a little bit of detail about this box. So what you need to do is compare the exponents of the top and the bottom of the numerator and the denominator. So we use n for the numerator and m for the denominator, and we're looking at the degrees, the largest exponents on both of them. So we compare them. If n is smaller than m, meaning the top is smaller than the bottom, then just by default, your horizontal asymptote is y equals 0. If they are equal, they have the same degree on top and bottom, then you use y equals a over b, so you're making a fraction, and a and b are the leading coefficients of those terms. So you're basically removing the rest of the polynomial, and then the front 2 terms, you're going to make an equation out of, or a fraction out of those. That's your asymptote. Finally, the last option, if n is larger than m, in other words, if the top is bigger than the bottom, then you don't have an asymptote. So let's look. The highest exponent on the top is 1, and on the bottom, it is also 1. These are equal. So we have case number 2 on the paper, n equals m. So y equals a over b. And these are the leading coefficients. So if we come back up here, the leading coefficient, LC, of the top is 2, and LC on the bottom is 1. Because in front of our highest term, we have a 2 on the top and a 1 on the bottom. So our asymptote is y equals 2 over 1, or just 2. So y equals 2 is our horizontal asymptote. All right, going back to the paper. Step 5 is to find slant asymptotes. That is not something that we cover in CP Precalculus. It is something that we cover in honors calculus, precalculus. So we're going to skip right over that one. Step 6, we need to find this information. x and y intercepts, domain and range. So y-intercepts, there's nothing special here. It's just the same way you have found y-intercepts this entire time. And yes, you can use your calculator for this, but your calculator does not always show you the y-intercept if your numbers are not whole numbers. If they're decimals, they might not show up. So knowing how to do it by hand is extremely important. To find the y-intercept, you just sub in 0 for x, as always. So our equation is y equals, from the top, 2x plus 1 over x plus 1, plug in 0 for both. 2 times 0 plus 1 over 0 plus 1. 2 times 0 is 0 plus 1 over 0 plus 1 is 1. So 1 over 1, which is just 1. So our intercept is at 1 on the y-axis, so we have to write it as a point for it to be correct, 0, 1. The point 0, 1 is our y-intercept. Now we find our x-intercepts. And I say steps lately because we could easily have 1. We don't have to have 2 or more. Now this first part I'm going to demonstrate on a post-it note, because if you're looking at the paper, you'll notice we don't have to do 0 for y for the x-intercept. We could, but we don't have to. Let me explain why. So typically, this means we would do 0 for y, which you can do, but there's a shortcut you will discover very quickly. So if I plug in 0 for y, I get 0 equals 2x plus 1 over x plus 1. The first thing I'd have to do to solve is to remove the denominator. To remove this denominator, I multiply by the reciprocal of this. Just this, not including the 2x plus 1. So this would be 1 over x plus 1, so times x plus 1, over 1 if you will. These will cancel. Multiply by x plus 1 over here. Well, that's still 0. So basically, it's as if I just take the numerator and set it equal to 0 and get my answer. And this works every time, because when you have something on the bottom and you need to get rid of it, you have to multiply it off, and you'll be multiplying by 0 on the left. So there's really no point in considering it. So the shortcut is set numerator equal to 0. Equal to 0. So our numerator is 2x plus 1 equals 0. Solve for x. So subtract 1. 2x equals negative 1 divided by 2. X is negative 1/2. And again, we have to write this as a point. So negative 1/2, 0 is my x-intercept. 2 more details to find, domain and range. Now these seem quite complicated because we're already talking about all the things that are not included in this graph. But actually, domain and range are pretty easy here. It's all real numbers except for the asymptotes. So, if we look back at the domain, this is the x values. So it's the vertical asymptotes that we're going to have to focus on. We've got 1. So it's all real numbers except negative 1. So I'm going to put that underneath here. All real numbers except negative 1. That's what this domain is going to describe. So negative infinity to negative 1, parenthesis because we're not including negative 1. This is when we use that union symbol. Remember, union is for jumps or gaps in the graph. And then we pick back up, not at negative 1, but after negative 1, and then we continue on our way to infinity. Again, this is literally saying every single number on the x-axis in the domain except negative 1. And that's because of the asymptote. Range, we're going to do the same thing. Except for range, we're looking at y values. So we're looking at the horizontal asymptotes, the y equals. So this time it's all real numbers except 2. Is what this is going to mean. So negative infinity to 2, union, 2 to infinity. Every number literally except 2. on the y-axis. Once we get all that information together, now we create the graph. This is going to be a very rough hand-sketched graph. Partially using the information we just found, and then the gaps that we don't know in the information, we'll use the calculator. First thing you want to graph are your asymptotes. So remember, we have a vertical asymptote at -1 on the x-axis. So it's going to look like that. Unfortunately, your calculator will not graph those for you. Next, a horizontal asymptote at 2 on the y-axis. And then we have 2 points we can plot. We have our x and y intercepts. So our our y-intercept is at 0, 1. And then our x-intercept is at -0.5, 0. Now, I know some people already kind of know that the shape of this function is kind of odd. It comes in hugs with the sides of the asymptotes. So as you can imagine with these 2 points here, that's exactly what it's going to do. It's going to come down and hug this one here and come up to hug this one. And you'd see that on the graph in just a moment. Reminder, for my class, you need to graph 3 points at least. We have 2, so we need to get a third one. Now, obviously, if there are not great points, you can allow some exceptions, but usually you can find one more, and there actually is one more on our graph. So first, here's our graph. And again, you can't see the asymptotes, but you can see how it's hugging the graph. And then if we go look at the table, if we go look at the table, you can see we have another nice point here at -2, 3. So about right there. So we're right about there. And then if we go back to the graph, we can see the general shape here. Looks like it starts to curve up before that. I'm going to kind of guesstimate here, honestly. It's not going to be perfect by any means. Hence, rough sketch of the graph. And there you have it. All right, let's continue and do another example. Example 2. F of x equals, and actually I'm going to write the bottom first. The bottom's bigger, I will write it first. So now I'm big to make my fraction bar. X minus 4 on top. So, go by our steps on our paper here. Step 1 is to factor. This one we can actually factor. The bottom does factor nicely. So, we're making 2 factors here. X minus 4 is on top. So, we need our x's in the front. And then the back numbers have to multiply to 5. Well, we only have 2 options, 1 and 5. And then when we add them together, we need a positive 4. Since this is a -5, we know the 1 is positive, 1 is negative. Since 4 is positive, that means 5 has to be positive, 1 has to be negative. If you don't believe me, feel free to multiply that back out. I promise you this does work. So we factored it. Next is we look to see if there are holes in the graph. There are no holes. Remember, holes are made when we cancel something from the top and the bottom. Usually when they give us a setup like this, we can guarantee that they're doing it to set it up so we can cross something off, but actually that didn't happen here at all. We could factor the bottom, but that was about it. So no holes still. 3, we look for our vertical asymptotes. So for this one, remember, we set the bottom equal to 0. You can do this with the factored or the original version. It's just kind of whichever one's easier. For this, I'll do it with the factored version. Since this is already factored, setting this equal to 0 and solving will be much easier. Plus, I would have to do that anyway. So let's do that. X minus 1 times x plus 5 equals 0. So then we're going to separately set these equal to 0. So we have x minus 1 equals 0 and x plus 5 equals 0. So that gives us x equals 1 and x equals negative 5. So my asymptotes are at x equals 1 and x equals negative 5. I have 2 of them. Fourth step is the horizontal asymptote. So this comes from the degree at the top and the bottom. So let's look. The degree at the top we refer to as n, and the degree at the bottom we refer to as m. N here is 1, and m is 2. So here we have n is less than m, which means we have the first case. In case 1 tells us if n is less than m, then y equals 0. So y equals 0 is our horizontal asymptote. And according to our paper here, I'll just stop there. I don't think we'll have totes. I don't want to say that and be wrong, but I feel like we wouldn't, because it sounds like we'd only have one. I could be wrong. Y equals 0. Step 5, we technically do not do, that is the slant asymptote. So step 6, we are going to find, right, skip. Step 6, we find x-intercepts, y-intercepts, domain, and range. So, for the y-intercept, could be steps, we don't know. Probably not. So we do 0 for x. So we can plug it into the original or the factored. I'm actually going to plug it into the original because this simplifies a little bit quicker. It's really not that big of a time difference, but this one you can more do mentally versus this one. So we have y equals 0 squared plus 4 times 0 minus 5. And then on the top we have 0 minus 4. 0, 0, negative 5 on bottom. Negative 4 on top. 4/5. And by the way, 4/5 is just 0.8, so it's actually a very nice decimal. So I'm going to write this point as 0, 0.8. Now this would be an example of one you couldn't easily get on the calculator because it is a decimal. Well, actually it does show up on the calculator because the x is still 0. So points removed, I guess it would still show you on there, which is nice. So on the table, you just look for where x is 0, you get your y value. Just an FYI. 7. Your x-intercepts. Again, this is just where you set the numerator equal to 0. So our numerator was x minus 4. So then x equals 4. So our x-intercept is at 4, 0. We only have 1. Domain and range. So the domain is all real numbers except for your vertical asymptotes. So for the domain, we are skipping 1 and negative 5. So this is going to look a little wonky. Negative infinity. Now, we have to do this in a specific order. We start at negative infinity. We move to the left, from left to right on the graph. So we're going to run into negative 5's asymptote first, since that comes first from left to right. So negative infinity, we come to negative 5, we skip it. So union, pick back up, negative 5. Then we move to the right some more, and we come and hit the asymptote at 1. So we can't have 1 either. So we're going to skip 1, pick back up after 1, and then we'll continue on our merry way to infinity. So this domain is all real numbers except negative 5 and 1, and remember these have to go in order. And we have this little interval here because the numbers from negative 5 to 1 are Between -5 and 1 are still included. They're still good, just not -5 and 1 themselves. Last but not least, we have our range. All real numbers except for our horizontal asymptote, which is at 0. So all real numbers except 0. -infinity to 0, union, 0 to infinity. And now we graph. Again, rough sketch here. Does not have to be perfect by any means. First thing I do is the asymptotes. So we have an asymptote at 1. And then we have an asymptote at -5. Yes. And then our horizontal asymptote is at y equals 0, which happens to be the x-axis. So this is going to be difficult to demonstrate, so what I really do is emphasize the dashed lines after I draw the x-axis. You can go over it and darken it a bit to dash it if you would like to do that, but you don't have to. Okay, so here are our asymptotes. Now let's graph our points. We had a y-intercept that was at 0 and 0.8. So it's just below 1. And then we actually had an x-intercept as well at 4, 0. Now this can be confusing because you might think, well, aren't you not supposed to be able to cross this because there's an asymptote there? I actually did not learn this myself until I went to college. No one told me, but I feel like we've been lying to you, and I felt lied to. A graph can actually cross a horizontal asymptote, but to my knowledge, it cannot cross a vertical, but it can actually cross a horizontal, and this graph does cross the horizontal asymptote. So you'll definitely want to go to your calculator to get the rest of the graph, because it is quite interesting, to say the least. This is what she looks like. So as you can see, this graph comes down and hugs our -5 asymptote here. And I want another point, so let's see if I can find another nice one. So let me go to the table. We've got fractions galore. Let me go the other direction. If I can't find another point, then like a nice one. 4, 0. Yeah, these are just fractions galore, aren't they? Okay, how about a compromise? Why don't I go to like a decent fraction? Like -2 2/3, I can graph that. So -2, and then 2/3 is going to be a little bit below 0.8. So it's going to look like something like that. There we go. There's an intentional point I drew. 3 points. I have met my minimum here. Graph. So this one looks like a parabola of sorts. So as you can see, it curves up and hugs this asymptote here. And then this curves up and hugs the asymptote on the other side. And then over here, I can't tell for sure if this crosses the horizontal asymptote or not. I'm curious. That would be something I'd have to really dig deep to find. So, looks like it starts to curve down right about here. Again, it doesn't have to be perfect. General shape is what's important. And 3 points. And then over here, as we found, and I clearly pointed out, it does cross the horizontal asymptote. Crosses, and then if you were to look at the fractions a little bit more closely, it very slowly is above the x-axis and moving up. Very, very, very slowly. So it basically rides along the axis from what we can see, and it keeps going. So yeah, there's our graph. 2 more examples. Example 3. Our equation is f of x equals x squared minus x over x cubed minus x. So first thing we want to do is factor. This does factor. So first thing we can do, we can pull out an x on the top and the bottom. If we plot an x, we're left with x minus 1. And if we plot an x on the bottom, we are left with x squared minus 1. So we can't do anything else on the top, but we can factor this on the bottom. You should recognize this is a difference of squares. So we can write this as x times x minus 1 over x squared minus 1 can be written as x plus 1, x minus 1, hence the difference of squares. And then x still is on the outside. And then we can start crossing some things out. So we can cross out the x here and here, and then the x minus 1s as well. So then we are left with 1 over x plus 1. Now, because we are able to cross this out, some things happen to our graph. There are other things we'll have to consider when graphing it. We can't just leave it like this. We have other things to think about. So, now's where we're able to talk about holes. So, holes, factors of the numerator cancel with factors of the denominator. So we canceled out two factors. So we canceled out x and x minus 1. So we'll have holes at x equals, and we're going to set these equal to 0. X equals 0 and x minus 1 equals 0. So at x equals 1. So we have two holes here. Now, this isn't going to be the line. It's whatever point is attached to these numbers on the x-axis. So we don't know the y values yet. So we'll get to those later. And then 3, vertical asymptote. And actually, before I get to that, I can find these now. So let's go ahead and do that, because I don't want to confuse and make you think that these are the same thing as the asymptotes. Let's find the actual y values that go with these. Now, we can't plug these two into the actual function, because these would come out as 0 over 0, which you cannot have. You cannot have 0 on the bottom of a fraction. But we can plug them into here, and this is where we will get the actual numbers. So let's do that. X equals 0. So we have 1 over 0 plus 1, which is 1. And then x equals 1 is 1 over 1 plus 1, which is just 1/2. So the holes are at, let me replace these, 0, 1, and 1, 1/2. So they're going to be holes on the graph, not points. We'll get to that later when we're graphing. Vertical asymptotes, this is when you set the denominator equal to 0. So x plus 1 equals 0. X equals negative 1. Now this is actually an asymptote. Horizontal. So this is where we go back to our function, and we do use the original one, not the new one we made. I mean, it does give you the same answer, but I don't want to be incorrect here. So here, n equals 2, and m, the denominator's degree, equals 3. N is less than m, so y equals 0. That's our asymptote. All right, then we just have to find that extra information. So step 6, you find the intercept. So we're going to find the y-intercept first. And that is 0 for x. And again, this time we're going to use the new and improved function. So y equals 1 over 1 plus 0, which is just 1. So our y-intercept is at 0, 1, which we actually know to be a hole on the graph, so we need to be careful there. Not 7. It's just another part of step 6. X-intercept, or steps. So the trick here is to just set the numerator equal to 0. So our numerator here is actually just 1. So we set 1 equal to 0, and we see that this is a false statement. So this means that there are none, which when you see the graph, this will make a lot more sense. We will not end up with any x-intercepts. Domain. All real numbers except for our vertical asymptotes. So let's see where those were at. Vertical asymptote at -1. So all real numbers except -1. So -1 to infinity, -1, union -1 to infinity. And then the range, all real numbers except for our horizontal, which I believe was 0. Horizontal asymptote was a 0. So range, -infinity to 0, union 0 to infinity. And now we graph. So let's graph our important information. We'll start with the holes. 0, 1, and 1, 1/2. So instead of plotting a point, we're going to plot an open dot, otherwise known as a hole. It's a hole in the graph, meaning that this point in the graph is not defined. There is not an actual point there. And then 1, 1/2, it's going to be like right here. So there's my other hole. And then vertical asymptote at -1 on the y-axis, sorry, x-axis. Horizontal was, again, the x-axis. So I'm just going to put some dashes along the outside so I know it's all of this. And then my intercepts. My y-intercept is 0, 1, which I've already graphed. It's actually a hole, not a point. And then my x-intercepts, I don't have any. So from here, this is where I go to my calculator, my graphing calculator, and type this in. So I want to show you guys something. I graphed both of these in my calculator, and something interesting happened. So the blue is the factored down version of the graph, and then the red is the very original graph, because I wasn't sure which one I should graph. So I graphed them together to see what would happen. Now, the red is the original, and then the blue, which you can't see because they lay on top of each other, is the new, is the new function. However, you can see a tad bit of blue. I don't know why you can see that. Peeking out right here. So I was curious, did a little digging. So this is that hole on the y-intercept at 0, 1. So I go to my table. Notice that for the blue graph, which is the new one after I factored everything out, 0, 1 is defined as a point. But notice on the red graph, which was the original, it is not defined. It gets an error, hence that hole. The same thing happens at 1. It's defined on the new graph once I factored everything and canceled everything out, but on the old graph, it's an error, hence a hole. So I thought that was really interesting. Something else I want to point out, asymptote at -1 on the table, it looks like an error message. So that's how you know you have an asymptote there, just an FYI. So I am going to remove the blue graph because technically the red graph is what we need to be looking at because that has all the things. That is the correct graph for this equation. So This is what we can use to get the general shape. And let me see if I can get, I've got technically 2 points. There are 2 holes, but we'll go with it. I'll count that. So it looks like we just have fractions that keep getting smaller and smaller. -2, -1 is a point. It's an actual point. And then we just keep getting fractions. So between these 2 holes and the point, I will allow it. That will be enough to create our graph. So then we just kind of fill in the shape. Make sure you don't go through the holes. You kind of connect them, but don't go through them because they're not actually points. Something like that. All right, we have one more example and this video is done. Example 4. F of x equals, I'm going to do the bottom first, x squared minus 3x plus 2, and x squared minus 4 on top. So, the top and bottom do factor. We'll do the bottom first. X squared minus 3x plus 2. So I know I've got my x's, and then 2, that's 2 and 1. We have a positive 2, so these are either both negative or both positive. To get a -3, I'd have to have -2 and -1. Multiply them back together, that's still positive 2. X squared minus 4, this is a difference of squares. So this is x plus 2, x minus 2. So we do end up canceling the x minus 2's, leaving us with x plus 2 over x minus 1 as our new and improved equation. So that was step 1, factor, we did that. Step 2, we need to address the holes where we canceled. We canceled out x minus 2. So we have a singular hole. X minus 2 equals 0. That's at 2 on the x-axis. And for the y-axis, to get the value, we have to plug it into here. We can't plug it into here, hence why it's a hole. So if I plug it in to get my y value, y equals 2 plus 2 over 2 minus 1. 2 plus 2 is 4. 2 minus 1 is 1, so 4 over 1, so 4. So 2, 4 is where this hole is at. 3 is our vertical asymptote. I'm just going to abbreviate that. So this is where we set the bottom equal to 0. So our vertical asymptote is we're going to use the new and improved equation for that one. X minus 1 equals 0, so at x equals 1. That's our vertical asymptote. Horizontal asymptote comes from the degrees of the numerator and the denominator. So let's look. Again, we use the original here, but you'll get the same answer, it looks like, with this one. So this one's just to be safe. So here on the top, n is 2 and m is also 2. When they are the same, that is case number 2, I believe, on our paper. There it is. Yeah, case number 2. N equals m, so y equals a over b. So let's go back up. These are the leading coefficients. So leading coefficients, and both of these are 1. So since it's 1 over 1, so y equals 1. 5 we skip. 6 we find the missing things. Y-intercept, 0 for x. And again, we do this in the new and improved equation. So we get y equals 0 plus 2 over 0 minus 1. 0 plus 2 is 2 over negative 1, which is negative 2. So our point is 0, negative 2. So that was the y-intercept. X-intercept. This is where we set the numerator equal to 0. So x plus 2 equals 0. So x equals negative 2. So negative 2, 0. It's our x-intercept. Domain and range. I'll just stack these on top of each other, since I know these are going to be not going to take a lot of room. Domain is everything but the vertical asymptote, so everything but 1. Negative infinity to 1, union, 1 to infinity. Range, everything but the horizontal asymptote, which is also 1. So the range is also going to be the same thing. Negative infinity to 1, union, 1 to infinity. All right. We have everything. Let's graph it. So we start with our asymptotes. Or actually, before that, let's do the holes. We have one hole. It's at 2, 4. Right here. I almost out of habit made it a point. 2, 4. That's our hole. Then our asymptotes, I believe they're both at 1. Vertical is x equals 1. Horizontal is y equals 1. So at 1 on the x-axis, got our vertical asymptote. And then at 1 on the y-axis, we have our horizontal asymptote. Okay. From here, we go to our graph to get, oh wait, we have our intercept, so we can plot. Let's do that real quick. Y-intercept is 0, negative 2. And then x-intercept is at negative 2, 0. And then let's see if we can find, even though we got the hole, I'm still going to try to find one more good point. Remember, when you put this in your calculator, it needs to be the original equation, not the new and improved one, because that will change. Really, it will remove the holes is what it's doing. So there's our graph. And let's try to find another point on this table. Oh, 4, 2. 4, 2 is a point. Let's do that one. 1, 2, 3, 4. Oh, 4, 2. Almost went up too many. I was going to say, it looks a little high. Okay. And then we've got 3 points, if you want to include the whole 4. And then we can just kind of fill it in using our imagination. So there's that. And then this one, you could have guessed, does connect in this manner. And there you have it. If you made it through this video, I really appreciate you. I hope that it helped. It's a pretty extensive process that we have to go through here. Good news is we give you all of the steps. It's just, do you know how to do all of them yourself? And then put them all on a graph with the help of your calculator, of course. If you have any additional questions over these notes, feel free to reach out to me via email or in person. Otherwise, I hope you have an awesome day. Bye!